Hi dear students. So in the last video we had discussed about reaction enthalpy and standard enthalpy of reactions. So today in this video we'll discuss about enthalpy changes during phase transformation. So phase transformations means when you consider a solid, okay, solid when you convert it to liquid, that is called as melting. That is solid when you convert it to liquid, it is called a phase transformation. Solid is a phase, liquid is another phase, gas is another phase. So from one phase to another phase, when you convert substances, it involve energy changes also. You should apply some, or you should provide some energy for phase transformations, that is to convert solid to liquid, that is to melt it. You know that you need to apply heat energy, isn't it? So there is some energy involved in such reactions. So enthalpy changes during such phase transformations will be discussed under this topic. Similarly, when you convert liquid to gas also, you need to apply heat energy, isn't it? Now that is called as vaporization. When you convert solid to gas, that is solid when you convert it to gaseous form directly, then it is called as sublimation. So you can see these three phases, that is, you can convert them, they can interchange them, isn't it? So when you interchange them, when you convert one phase, that is when you convert the substance from one phase to another phase, there is some energy involved, and the enthalpy change during such phase transformations is discussed here. Now just consider this equation, that is this reaction, that is water. You can see H2O is, H2O gives H2O, that is H2O in solid form gives H2O in liquid form. That is solid form means it is ice. Okay, so ice, when you apply heat, when you provide some heat energy, it get converted to liquid, that is water. Okay, so during that conversion, the enthalpy change, that is change in enthalpy delta H, it is given as 6 kilojoules per mole, and you can see the simple written, that is delta fusion of the H, and you can see a superscript also, that is standard enthalpy of reaction. So this simple, that is delta H, you can see a superscript with fusion, that is called as standard enthalpy of fusion. So this simple is called as standard enthalpy of fusion. Okay, so standard, you can see that superscript, it defines or it indicates the standard form, that is all the substances are in their standard states. So this is called as the standard enthalpy of fusion. So the enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion. That is, what you say, when a substance is converted from one phase, that is from solid phase to liquid phase, the enthalpy change accompanying that reaction, that is called as the standard enthalpy of fusion. That is from solid to liquid, when you convert, what is the change in enthalpy, that is the enthalpy of fusion. Okay, now if you consider this reaction, that is again H2O, it is converted to H2O, but you can see H2O in liquid, that is water, it is converted to water vapor in gaseous form. That is, you have to heat water and you will get water vapor, isn't it? So the enthalpy change accompanying that reaction is given as delta H, you can see vaporization with the standard state, and that is 40.79 kilojoules per mole, isn't it? 40.79 kilojoules per mole, and this simple, that is delta H with a superscript vaporization, that is called as the standard enthalpy of vaporization. Okay, so you can see change in enthalpy with a superscript that indicates the standard form. So delta H with a superscript vaporization, it is called as the standard enthalpy of vaporization. Okay, so the amount of heat required to vaporize 1 mole of a liquid at constant temperature and under standard pressure is called its standard enthalpy of vaporization or molar enthalpy of vaporization. That is to convert what liquid to gas. Okay, to convert liquid to gas, how much amount of heat is required, or what is the change in enthalpy? That is called the standard enthalpy of vaporization. Okay, from liquid phase to gaseous phase, that is standard enthalpy of vaporization. From solid phase to liquid phase, that is standard enthalpy of fusion. Okay, now one more is, last one is the delta H. You can see with sublimation. Sublimation means, I have already told, it is solid directly converted to gaseous form. Okay, solid to gaseous form is sublimation. So this symbol is called the standard enthalpy of sublimation. Okay, now what is standard enthalpy of sublimation? That is standard enthalpy of sublimation, that is delta sublimation H. It is the change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature and under standard pressure. That is, 1 mole of a solid substance, when it is converted to a gaseous form, what is the change in enthalpy, or how much energy is required? Okay, that is called the standard enthalpy of sublimation. Now the next topic is standard enthalpy of formation. Okay, that is the next one. So the standard enthalpy change for the formation of 1 mole of a compound from its elements in their most stable states of aggregation, that is also known as reference states, is called standard molar enthalpy of formation. That is, standard enthalpy change for the formation of 1 mole of a compound. You know that elements, that is in the periodic table, you know there are a lot of elements, isn't it? So these elements, they will combine to form compounds, isn't it? So when these elements, when they combine to form 1 mole of a compound, what is the change in enthalpy? That is called the enthalpy change of formation. That is, when elements combine to form 1 mole of a compound. Please note that point, that is 1 mole of a compound. If it is more than 1 mole, it is not called, it is not referred as standard enthalpy of formation. It is not called as the standard enthalpy of formation. It is just called as the standard enthalpy of reaction. Okay, if it is 1 mole, the elements formed, if it is 1 mole, sorry, the compound formed, if it is 1 mole, then it is called as the standard enthalpy of formation. Otherwise, it is just a standard enthalpy of reaction. So the enthalpy change for the formation of 1 mole of a compound from its elements, that is, when elements combine and when they form a compound, and if it is 1 mole, then the enthalpy change accompanying that reaction is called as the standard enthalpy of formation. Okay, and for this, these elements which is combining, it should be in their most stable states of aggregation. These elements should be in their most stable states of aggregation, or they should be in their reference states. Now what do you mean by most stable states of aggregation or reference states? That is, the reference state of an element means it is its most stable state at 25 degrees Celsius and 1 bar pressure. Okay, at 25 degrees Celsius and 1 bar pressure, which is its most stable state, that is called the most stable states of aggregation. Okay, now if you take an example of carbon, you know that there are many forms of carbon. Okay, so at 25 degrees Celsius and 1 bar pressure, graphite, carbon in graphite is the most stable state, so that is taken as the reference state for carbon. If you take sulfur, there are many forms of sulfur, but at 25 degrees Celsius and 1 bar pressure, rhombic sulfur is most stable, so it is taken as the reference state. So that is called as the most stable states of aggregation or reference states. So these elements should be in their most stable states of aggregation, and when they combine, they will form compounds, and that should be 1 mole. Then that enthalpy change accompanying such a reaction is called as standard molar enthalpy of formation. So the symbol for the standard molar enthalpy of formation is delta H, then you can see a superscript of standard states, then F means it is formation. For fusion, it is not F, it is FUS. Okay, fusion is FUS and formation is simply F. Okay, Now if you take these examples, you can see H2 plus half O2 gives H2O. Okay, and the enthalpy, standard enthalpy change of formation is given there. Similarly, C, that is carbon graphite. Okay, so carbon graphite is actually the reference state, I have already told. Plus 2H2 gives CH4, it is capital H4 it is. Okay, and the standard enthalpy change for the formation is given. Even carbon, one more reaction is given. 2 carbon plus 3H2 plus half O2 gives C2H5OH. You can see these products, that is water, methane CH4 and C2H5OH. You can see all these products formed are only 1 mole. Their elements, let it be any number of moles. Okay, but the compounds formed, they are only 1 mole. So it is written as standard enthalpy of formation. Now if you take this example, H2 plus Br2 gives 2 HBr. You can see 2 moles of HBr, that is product is formed. 2 moles of compound, HBr compound is formed. So for such a reaction, you can't write it as standard enthalpy of formation. You just have to write it as standard enthalpy of reaction. So you can see it is written as delta RH, not delta FH. So for formation, it should be only 1 mole of the product. If it is more than 1 mole, it is written as enthalpy of reaction, not formation. Okay. So by convention, standard enthalpy for formation of an element in reference state, that is the most stable state of aggregation, it is taken as 0. Okay, that is standard enthalpy for the formation of an element in reference state, it is taken as 0 for calculations. Okay, thank you.